Alrighty, guys, we're going to get started. This is the Beyond IPv4 Designing Autonomous Networks with V6. My name is Dennis Burgess. I have wrote a couple books about Router OS. I work with Link Technologies, Inc. We are at booth 413, I believe. Please stop by and see us. Everything else is right there if you have any questions. We're going to cover quite a bit in here. I put these slides together to, again, the slides will be available probably right after the show to give you the information. I'm not going to read the slides, obviously, but again, IPv6. How many people in here have deployed V6? Okay, a couple of you. Great. How many of you have V6 addressing but have not deployed it? Okay.
A lot more.
Shame. Is WISPA in here? I don't see no red shirts, so okay, I can't give them. I've been trying to get them to get on that bandwagon for quite a while. Again, IPv6 is really not optional anymore. I would highly recommend that you start deploying it. Justin here is going to go after me, and he is going to cover a lot of the basics of V6, how it works, that type of stuff. And then Jeremy actually has a great single stack use case that he even has a demo and all that fun stuff. So that's what we're going to do, and I'm just going to kind of go through this pretty quickly here. And again, I'm going to ask some questions. So is there any operational lessons? So again, I have been running for V6 on my network for at least 10 years, if not more. I know Jeremy's been running it for probably 10 years. Is there any operational lessons that you need as an operator that you have learned that you would want to tell everybody that they need to know about V6? Pick one, anyone.
Yeah. I think you went the other way.
Yeah. Technical stuff. Some of mine's philosophy. One of the first ones is your CPE, your backhauls, all that stuff. They don't need IPv6 addresses if they're management addresses. If you're dual stacking, so cut that out right away. Yeah,
There's also the fact that most management systems don't really handle V6 very well.
Very true.
We do, but no. A lot of NMSs just, for one thing, there's no concept of like scanning a network to find all the addresses on it. You don't do that in IPv6. Mm-hmm. So if you had kind of poor practices about how you were managing your infrastructure and you didn't have assignments for your equipment, you could scan it in V4. It can't scan it in V6.
So I actually have an interesting story on IPv6 security. If you scanned 5,000 IPv4s a second, you would scan the entire IPv4 internet in like 12 hours. Okay? A single /64, which is the smallest size that the stateless autoconfigure can configure. So on a typical LAN network, a home network, you would have a minimum of a /64. If you were scanning at the same speed, it would take like 16 years to scan that individual /64. So the numbers are so incredibly huge that even scanning for those is very difficult. And as Jeremy mentioned, you're not going to be able to scan and discover items. So with that said,
with V6, you don't think IP addresses, you think subnets.
Yeah, everything's a prefix.
Yep. VLANs and prefixes. I can think of one from the field where, when you get down to the actual customer experience side, there are websites that, even though they nominally support both stacks, I've seen cases where somebody had, geo-blocking and it was badly done, right? Mm-hmm. And so usually the choice that an end device makes to either use IPv6 or IPv4, that's called happy eyeballs, and that algorithm lets the device, say, hey, I have V6 available to me, I'm going to try it. It basically chooses whichever one's faster, kind of. That does not always work. And so sometimes you might find yourself troubleshooting an end user problem that really is not, you say, well, it works fine on V4, it doesn't work on V6, So I can think maybe once a year I've run into this and then had to do something like put in for what that customer put in a V6 firewall blocked. Say, just don't even try hitting that website with v6.
Yeah.
But that's not your network's problem. That is the problem of whoever's deploying on the far end. That just could be something that you might end up having to troubleshoot connectivity a little bit. Just don't assume that it's working on v4, so it must be working.
Yeah. Whenever you deploy v6, one of the other operational lessons that I have learned is training of your support staff. Because one, they have to know that there is 2 separate protocols running. They have to know which one they're actually trying to connect to. And a lot of times I'll get, hey, XYZ customer can't connect to this URL. Well, that URL is going to be translated via DNS to either a v6 or a v4 address or both. And in that particular instance, you need to be able to troubleshoot which stack am I using or which one am I trying to connect to. Because I have seen a number, mostly small banks for some reason, where they have deployed v6 and they're handing out v6 addresses, but their web servers aren't listening on v6. So if you try to get there, it tries, and it makes your internet seem, I'm going to use air quotes here, slow, because it tries on v6, it can't connect on v6, and then it fails back to v4. So that is one of those things that whenever you are an operational lesson is you need to make sure that your support staff and whomever is taking care of your network and whoever's handling that frontline support knows that you're actually running both stacks and how to do that troubleshooting.
But the tools other than that are very much the same.
Yes, yeah, I mean, they are, it's just the numbers are exponentially bigger and they have letters in them. How many people are scared by letters in the IP address? I got a couple.
We got one honest person.
Gotcha. There are several government entities that require v6 access if they are getting DIA. So just as an FYI, if you're looking to sell to a government office, some type of form of government, they have mandated in many cases that you must be able to offer v6. So honestly, there's not really a reason why not to, other than you have to deploy it, et cetera. So originally, IPv6 is no longer this upgrade project. We have to continue on. We need, especially as WISPs, we are, they used to say we're the scrappy operators. We should be deploying v6 because guess what? There are big companies that are doing it and they're doing it very well. We should actually be doing it better than them because we're the scrappy operator. That's my opinion anyway, but AT&T, Spectrum, all these companies are actively deploying v6, and if you are not, you're gonna really be not necessarily hurt, but be left by the wayside, especially in items that government contracts, things like that. You will need to do that, etc. I already went through the dual stack question, so next slide here. So something that IPv6 helps with, all of a sudden we don't have NAT. How many people NAT private IPs on the v4 to v4 public IPs for their customers in here? So with v6, that goes away. An example of this, and I'm going to use a very specific example. PlayStation is not one of them because Sony sucks, but that's a whole nother ballgame. But Microsoft Xbox services, all of Xbox services are v6 dual stacked. And by you adding v6 onto a customer, all of a sudden their NAT strict goes away. And it literally basically takes what is a problem for people who are trying to game online and removes that problem just by going to v6. There was another service, I can't even remember what it was, but on a network that is true dual stacked and is v4 and v6, and this is one of my customer networks, almost 70% of that traffic is v6. Okay.
Which means that the devices are preferring v6 because it's faster.
Oh yeah. There is it is faster. Number one. Number two, YouTube, Facebook, Google, even Paramount Plus, Disney, all of them are already dual stacked. So by you deploying v6, your network should seem and operate quicker because v6 is typically quicker in operation. But you also, like I said, you don't have to go and consume CPU resources for
Right.
CGNAT. You don't have to consume.
Right, it reduces load on your network.
Yeah,
to
it
do
will reduce
Yeah.
load on your network overall. So, with that said, if you were starting today, would you do dual stack? And if you did dual stack, what is the biggest blocker? Is it the CPU? Is it the staff? Is it training? Is it the customer device? Again, real world deployments that work. V6 only, we have dual stack, or IPv4 only. Which one of those is the technology? Greenfield network, starting brand new. What would you do?
I would definitely do dual stack. The challenge would be the authentication system, whether you're doing radius, you're doing, as Dennis had up there, triple PoE. The radius or the authentication piece is the hardest piece, because you need a system that understands, hey, how do I drop both V6 and V4 for the customer? How do I turn both of those off? How do I authenticate both of them? That's the biggest challenge starting new. There's cookie cutter plans for, and I'll go through some cookie cutter plans, but there's plans to, hey, who do you assign this to? How's it assigned? That stuff's pretty straightforward these days.
In my case, I think it would depend on what kind of a network it was. Most of the issues that Dennis mentioned are really going to drive that decision. So to give an example of a network where you have a single stack core, IPv6 in the core, and V4 as a service or an overlay kind of, those can be very attractive from a network management perspective, but they require that you really own the endpoint that does that translation. So for example, all your cellular networks are that way, Starlink's that way, where there's one network protocol. I'll talk a little bit about that in my demo, of some of the advantages of that. But it's hard for a smaller ISP, even a medium-sized ISP. The work of spinning up, like a central concentrator and doing MAP-T or something where you're doing a translation between V4 and V6. I think it's like, how long is a piece of string? You have to figure it out in the network specifically, whether that makes sense for you, whether those costs make sense. Dual stack is, apart from the kind of the authentication question, certain platforms do that pretty easier than others. If you have a BRAS that supports dual stack, and you have it can be simple depending on how rigorous you are about designing your plan there. So I'm sorry that's not a solid answer, but I would say in most cases dual stack is going to be just fine.
Yeah. I mostly design dual stack networks. We do a very few 2.5 layer 2.5 networks, so either MPLS or VXLAN. Those networks, they are very specific. I.e., you have a single data center that might have multiple connections, but everything goes back to that one data center. As soon as you add a second data center, the whole layer 2.5 thing kind of gets much, much more complicated, because now you have to integrate layer 2 services with multiple exit points. I'm not a fan of doing that. I prefer just layer 3, both in V4 and V6. But again, to each his own. I would always sit there and explain, here's the pluses and minuses of both. It's up to the customer what they want.
Right.
I mean, it's their
what
it's their
products
network.
they intend to sell on that network. It's
Right.
it's gonna
So, all right. Well, with that said, again, if we have any questions, this is the last session of the day. So my assumption is that they're not going to kick us out if we go over. We're hoping. So if you have questions, please ask. With that said, Justin Wilson's going to come up here and give his presentation.
Thanks, Dennis.
So a lot of people know me, so I wear many hats. I run an internet exchange, do a little consulting on the side. Everything you need to know about me is up there. My only ask is I do a regular blog. If you want to subscribe to it, please do. I've been in the industry for quite a number of years. So we're going to start out with, what does a bad V6 deployment look like? And we'll get into what some of these mean later, but the the idea is this is what you don't want to do. One of the things that like Comcast does to me at home, I get something smaller than a 64 prefix, and that breaks quite a bit of stuff.
Smaller than a 64? You mean?
Yes, they
That's
assigned
crazy.
me it's a 72 at the moment.
Oh, that's bizarre.
Yeah, it's quite bizarre. My MikroTik
Are they
logs
reserving like the rest of it for the loopback on the network? You know?
I haven't figured it out. My MikroTik is full of all these
72s.
RA logs, and it's
Weird.
just a mess. When I get home, I'm getting joint, and I'm going to tell Comcast to go take a leak.
Shove it.
I'm ready.
Didn't Spectrum just buy Comcast?
I'm not paying attention.
One of the things that I see people do is they do an inconsistent addressing. With V4, people are used to, hey, I don't have enough space, so I got to make this 29 work. I don't have a 28 that really should get here, but I'll do a 29 and I'll figure it out later. I'll put another 29 in there. With IPv6, you have the room to do it right the first time and do it right once. Firewall policies are another thing. Protect your V6. People often forget that. Reverse DNS, it's a thing. Netflix, most of the CDNs, they pay attention to not only geolocation, but they pay attention to your reverse DNS. That goes in their special sauce of, hey, who do I or where do I serve your content out of?
Yeah.
Instead of serving it out of Seattle, Washington, when I'm in Indiana, it'll serve it locally. And as Dennis said earlier, it gets a little complicated doing reverse DNS for a quadrillion IPs.
Yeah, it has to be dynamic.
Yes.
Yeah.
Oh, yeah.
MTU is a thing with IPv6. You're carrying more stuff in the header.
Don't block ICMP.
ICMP.
Yeah.
Yes.
Do not block ICMP. I'm just going to reiterate that. It will break
It
V6.
will break V6. And people are like, well, why? Well, we could get into a discussion about it, but don't do it.
Yeah.
And then, no route aggregation plan. So if you're a big ISP and you have, regions, or you have, pops that, hey, this is a large pop that serves, 20 micropops or 20 sites underneath it. You need to think, hey, I have enough space to say, hey, I'm going to, it's going to be overkill from what I'm used to in the V4 world. So if you aggregate, and it's all a big math calculation. So if you aggregate things on that level, your routing tables get smaller, and it's better for your routers.
And they're easy to read.
Easy to
IPv6
read.
routes are actually easier to read than IPv4.
And also keep in mind, in the planetary scale, they assign IPv6 blocks by country. So when you're in the United States, you're out of this /8, which is still 65,000 /8s that we have in the planet. So you can easily say, hey, I don't want anything from China, or I don't want anything from Russia. And for your firewalling, and all you have is one prefix, and that's it.
IANA has said,
Yeah.
hey, we're not going to allow inner transfers.
Yeah,
like
yeah,
they've
they're
done
not going
with
to
V4.
they're not going to transfer from Germany to Latvia or anything like that.
Because there's just no reason to.
yeah.
Yeah,
There's
there's
no
no
reason.
reason. So what happens when V6 goes right? We've talked about some of this, no NAT, your streaming gets better. You don't need these large carrier-grade NAT boxes.
Well, even if you're still doing some, you'll have less load on them
Yes.
because there are
Less
fewer
load
of your sessions will be using that.
Mm-hmm.
And, MikroTik doesn't do carrier-grade NAT, natively. There's hacks and whatnot, but it doesn't do it. So, you'll have the better performance to any of the CDNs. Akamai, all the streaming places, Cloudflare, all these folks. And this is a little bit of a stretch, but if you're looking to sell, you'll be a little more valuable. You can make the argument, hey, I'm running a modern network.
I have one thing, because we run dual stack, we're going to be, because of IPv6, we can comfortably put a 300 unit apartment complex in a single IPv4 address. Because about 75% of all connections are V6. So that load is not on the V4 side, so we can really overstack the number of units on a single V4 address.
Yeah, so just to reiterate what you said, basically, because he's running V6, he can load more V4 IPs on a individual public IP, basically letting you use either less V4 addresses, et cetera. And that's mostly for our recording that we are doing here, so just an FYI. We would appreciate if you have any questions, if you can hit the microphone, but it's not a big deal. I can repeat it.
So anybody that's ever talked to me for a little while, I like philosophy and network. You can ask 6 engineers how to do something, you might get 10 answers, and they all might be right depending on the perspective. So one of the things is stop thinking about addresses. There's too many addresses to think about. People, that's one of the most common questions. Well, there's all these addresses. I'm used to V4. I need to conserve them. No, you don't. Think in subnets. And then consider all the pieces: DNS, reverse DNS, RPKI, route registries. Don't forget your V6 when you're doing all of this. Like I said earlier, I'm of the philosophy, I don't need V6 management addresses, and half the gear out there doesn't work right on them anyway. There's enough RFC 1918 space to do 10 dots or 172, so.
Or Publics.
Or Publics,
Yeah,
or carrier grade, or 100.64s, or,
Public loopbacks are really nice.
I'm pretty sure on a /64 there's 18 or 16 sextillion IPs. It's a lot of zeros.
It's
Just leave it at that.
Irrelevant. Yeah.
Have an addressing plan. The addressing plans get a little murky. Aaron's done some webinars where Aaron says, hey, we're not telling you what to do. We've brought this person in, and I've sat on 3 of them, and all 3 of them have been different things people should do, or what they think they should do. So what I'm going to tell you here is my philosophy. Yeah. Tools help. PHP IPAM, Netbox. You can say, hey, I want to pull out a /48. I want to do what I'm talking about here. Every POP site, I want to do a /48. Every routed interface at that POP site, I'm going to have a /52. And then the customer gets a delegated prefix of a /60. And this gets a little murky if you're not familiar with V6. So this is just kind of, hey, this is how I do it. When I set up my networks as cookie cutter networks, this is what I do. Dennis may have a little bit different philosophy on it.
I typically will, at a POP site, I'll put a 48 out there. And then any dynamic or like residential customers will get a /60. I would definitely agree with that. A /60's 14 /64s, so that gives you 14 networks per residential subscriber.
And your router as a customer, they're going to take that pool and say, hey, I have a /60 to pick from.
Right.
I'm going to pick a single subnet, which is a /64. I'm going to pick that, and that's what I'm going to assign to my LAN devices.
Right. And then you can have a guest network that will get a second /64. Now, if it is a business, and keep in mind, if you're getting a /32, you have a lot of /48s. If it's a business and they say, hey, we need a /48, I'll assign it. It's not complicated to do. Okay, I don't need anything like that. And then on BGP interfaces, I usually put /64s. They're static, but we usually assign a /64.
And a /48 is kind of like a 24 in the V4 world. When you start talking BGP, a /48 is the accepted standard of what people will accept via BGP. Yeah. If you're a BGP speaker in V4 land, you have to advertise a /24 or bigger, 23, 22, and on. With V6, it's 48 and on, down to, the typical
It's really
ISP.
nice. Yeah, you can have a distinct routing policy all the way down to an individual business customer. Mm-hmm. I follow the RIPE guidelines a little bit more closely, but essentially you're mapping your network, your regionality and your POPs onto the levels that you want to organize by. And, so even in a 32, there's space to do that a bunch of different that I tend to do 56 for residential, but that That's kind of the current ripe guideline there.
Yeah.
But it doesn't really matter a great deal. The important thing is you got to give them more than one. You can't just allocate a /64 to an end customer. So.
And it's and this is where Jeremy can probably explain it a little more because he's more analytical brain than I am. It's all about the nibble boundaries. So you have a /48. You don't want to do a 49. You want to do
It's
a 48.
easier to read if you do 4-byte boundaries. Yeah.
Yeah. So 48 becomes what, a 42, or what, 44?
44, 40.
So,
yeah.
but you don't want to do a 45 or 46. It gets messy.
And just so everybody knows, when we say nibble boundary, the analog to that in v4 is if you have a /24, that's right on the nibble boundary. Your last octet is all the hosts.
So we put the dots at 2 nibble boundaries.
Right.
Yeah.
So if you go down to /29s, now you have a whole bunch of subnets within that /24, and that would be inside that nibble boundary. And that's what you don't want to do. You have plenty of IPs.
Yeah, you have
don't
plenty
need
of
to do
IPs,
that.
plenty of subnets to say, hey, I don't have to be frugal with this.
Right.
Right.
I just have to be smart about it. And one of the lessons I've learned is don't necessarily follow what Zayo and Cogent and Hurricane's good, but don't necessarily follow what your upstream provider has laid out. I'm in the process of fighting with Zayo at the moment on a transit circuit because we have 16 BGP sessions we need to layer on this circuit. It's a layer 2 circuit, but we have all these different companies behind it. It's a co-op. So each co-op member has their own ASN. And Zayo comes along and says, we're going to give you a /127, which is the equivalent of a /30 in IPv4 world. And all of your members are supposed to fit on that. And we're like, no, that's not going to work. And so we're at level 4 of engineering at the moment to say, you guys have surely done this before. So don't necessarily follow what you think the big guys are doing. So, this is kind of what I had in the chart before, single 48 for all your infrastructure. So any of your point-to-point links, I like to pull all of those out of their own 48. Don't pull them out of the ones that you assign to your different POPs and things. You have a 48 infrastructure that is just for your point-to-point links, your loopbacks, any of that stuff. And this is where it, some of the philosophy comes into, because I like to do a /64. I'll set aside of it in NetBox or PHP IPAM, wherever I'm laying all this out. And I'll say I have a /64 for point A to point B. And then out of that 64, I pull a 126, which is essentially in IPv4 land, it's a 29. And here's why. Why I do a 126 versus a 127. And it's a subtle difference.
Yes, that's very nice.
Yes, because with a 127 in IPv6 land, you have 2 hosts, and the first host is either, I denoted it as 0. A lot of folks note it as : And so you don't have a number in that. So when you're talking to somebody, hey, I need you to ping the other side of this network. I need you to ping .0. People are like, what? If you've never worked with V6, it's
Perfectly valid. Yeah.
90% of the calls I've had, they're like, I have to explain it to them. So I've just done a 126. That way their side is number 1 and my side's number 2 or vice versa. So, that's one of those tricks because the 0 breaks my brain.
It's the same thing with v4. If you have like a /23, then right in between there, the 255 is valid, and so is the 0. It's valid if it's an actual /23. So kind of the same thing, but most people don't equate that to
You're used to thinking
something
of
that's
network and
usable.
broadcast
Right,
addresses.
right.
Yeah.
Yeah, they think, the first usable IP should always be 1. Well, in V6 land, it's not.
Right.
And, just do it. IPv6 really, one of the last things I'll say is one of the things I like to do with V6, if you've never done V6, I'll go through the entire network and I'll do all the backbone. I won't touch anything related to the customer. I'll do all my point-to-point links, backhauls, whatever, and I'll get that all working, from endpoint to endpoint, and I haven't affected anything with the customer. And I'll make sure all that works. Then you can go through and say, hey, I want to do this site. I want to, put customer addresses and all this on this site, and I can put them in one at a time or multiples, whatever I want to do. But it's not, you've already tested the road. Now you're just, hey, will my car work driving on that road?
I also would like to point out that, for those of you that may not know this, V6, at least in Microtech, is a completely separate protocol stack. So you have to run a separate IGP. So you're going to run OSPF v3 versus OSPF. And OSPF v3 is just for IPv6 addressing. In most of our IPv6 rollouts, we assign a loopback, and then we assign our point-to-points, and then we assign a /48 for the tower site. We will do that, go through all the routers, and then the next step is to mirror our V6 costs to our V4. And there's plenty of scripts out there to do that. If you want to use a script, you can, or you can sit there and go in there and actually manually define, hey, this interface is cost of 10, this one's cost of 4, whatever you want to do. We actually typically, especially if we're just overlaying V6 on top of it, we would use that script to simply mirror the exact cost of the OSPF stack to the OSPF v3. Once all that is deployed, you're going to have all of your V6 connectivity. You need to make sure everything's actually connected, which is important. And then once you have verified all that, then you can go ahead and set up your DHCP PD or whatever you're going to deploy your V6 with to your end customer.
Yeah, awesome. That helps it share fate there when you're making sure that your costs are the same. So
Yeah.
I'm going to do, this will be pretty quick. I do have the demo that Dennis mentioned. I have this running on my laptop, so I'm not going to show it to you here live, but if you want to see it live afterward, we can spend a little more time on it. This is something that I've wanted to do kind of as a proof of concept. I actually have it in production now, but I've wanted to do this about 10 years. And it took a little while because you could do it on other platforms than Microtech, and I wanted to do it on Microtech. And it took, until, when did RouterOS 7 kind of go stable? It was like 6 years ago?
Happened like 3 months ago.
Well, I know, yeah, 3 months ago. So, but from when they first released it till now, yeah. That is how, how long I've been waiting for RouterOS 7, and prior to that, I was waiting for any release of 7. Microtech has supported RFC 5549, which I'll talk about here. They've listed it in green on their website for a number of years, but it wasn't fully functional. And I had a couple tickets open with them that finally closed. Yeah, it was, I want to say 2 years, 3 years maybe.
Yeah, so RouterOS version 7 came out December 7th, 2021.
21, there we go. So, so about close to 10 years they've been wanting to do this. And the basic idea is there is no reason why you cannot pass IPv4 traffic to an IPv6 host. The actual packets themselves don't care, right? On the Ethernet layer, you're just handing it off to another MAC. And this RFC was developed a while ago now to allow you to have a single stack network underneath, just V6, but still be able to pass V4 traffic. And I'll talk about why you might want to do this, but mostly this is just a thought exercise. It's not something that I'm advocating you go run out and do, but it's something that you can do if you want to experience what this is like to live in a world where instead of V4 being your fallback, V6 is your network. And so RFC 5549 has been superseded by 8950, just a slight update to it for MPLS labeling, some improvements there. But essentially it's with long fancy name, but it basically means V4 routes with a V6 next hop. There's the RFC. So starting from this, I think both Justin and Dennis mentioned a little bit about, what happens when you go from a traditional single stack network to a dual stack. We're going to make the assumption that you kind of have a traditional core where you've got reachability is in OSPF. Version 2, that's going to be using your IPv4 reachability there, and then you're going to use an iBGP of some kind, probably BGP. IGP of some kind, probably going to be OSPF, and then for your traffic customer routes, they're going to be in BGP or maybe ISIS if you're fancy. I actually have some RIP in some cases. There's a variety of RIP v3. RIP v3.
I literally had a customer this past week that has like 400 RIP routes on his network. And I'm like, I haven't seen RIP in like 10 years.
Well,
or
so
something
RIP
like that.
v3 for v6 is actually a useful way of handling. It's how cable networks do it that way. They hand v6 off with RIP in some cases. And then, but addressing you've got netbox, you've got IPAM of some kind. You are having to manually manage all of those point-to-point links that Justin's mentioning, and you're probably using RFC 1918, which means that it's not really truly visible, and it makes your ACLs a little bit complex. And you've got your control plane, your firewalling. Generally, if you're not running VRFs, you're really trying to separate your customer traffic from your management traffic, and it gets kind of complicated. Out at the edge, you're peering with your ISP, you're using EBGP, and you're just using single stack IPv4. When you add in a IPv6 here, I think the reassurance we're hearing from our other panelists is it's not that hard. It's stuff you already know how to do. It's just kind of twice as much, roughly. You have OSPF v3. We've added that in. BGP is still here. We just have v6 sessions. And then one thing that you can do for your point-to-points, however, with OSPF v3 is there's no reason at all that those have to be static. You can do entirely link local if you care. In some cases, you might want to see those addresses in a trace route, and that would be why you'd want to do what Justin was mentioning. And then you have to make a decision. Am I going to have my control plane be dual stack? I think we were recommending no reason for it to be dual stack. Explicitly, it can be v4 only if you want. And then we just add that edge peering with a v6 session, and now presto, we have IPv4 and IPv6 routes that we can then distribute to our customers. So what I'll be demoing here is this is the simple dual stack core where you have a single stack. Sorry, I think I mislabeled that. No, I'm still calling it a dual stack core. Okay, it's not a single stack. And so we're using just OSPF v3, not both versions of it. We're using just one version of BGP, just v6. We're using link local addressing in this case, and you can do VRF, simple ACLs, whatever that you want, since you can do it via a v6 firewall. And then their edge peering can be dual or single, whatever your provider supports. Some providers are going to be able to support passing v4 and v6 routes over a single session, and some will not. And that also gives you the opportunity to dynamically route to your end hosts. You can do this. I have this in production today where I don't want to use VRRP. I mean, Dennis, we were talking about some of the disadvantages of it. You can get in a split brain scenario where you have partial reachability, and then upstream, it's non-deterministic where those packets are going to end up. There's no way for VRRP without automation to signal reachability upstream. It's really a very local failure domain. Whereas if you do dynamic routing to a host with bidirectional forwarding detection, BFD, you can immediately switch over to an alternate path or manage that reachability directly. So I really like dynamically routing all the way to the end host. And in this case, you just use link local, so you don't need any configuration on the host other than the BGP configuration. But I'm not going to demo that. So that the test architecture here is IPv6 and IPv4 on the right-hand side, the internet. I'm using, in this particular case, I'm not doing an IGP, so I'm just doing DHCP prefix delegation, which is why you see a 61, a 62, and then all the way down to a 64 is being handed off in this test example. There's no IPv4 in the middle. R2 doesn't have any IPv4. R3 is just doing NAT out to the cloud, and then we've got I've got a little VM with a little Linux client on it for doing a test web page with Chrome. So on the right-hand side, config is pretty simple. There's really not much more config than this. We've set the identity on the router. We've given it a loopback, so we can see that in our traces and have a route, something to advertise via v4. We're doing a little masquerading there. We've got we're advertising our loopback, and then we've added a BGP instance here, an ASN there, 65003, so we can see that. And because I don't have an IGP, I'm doing next hop for self. If you have an IGP, that's going to be distributing the hops. But normally you wouldn't be using that. And then I have a manual. Here's our actual routing connection over to R2. You can see that I have a link local address for my local address here. So it has a link local they all start FE80, and then in this case it also is appended with the interface name, because you have to have the interface name in there to know which interface to use. And then I'm pointing it at the remote address, which is on this link over to router 2. And here's what our route table looks like on R3. We have a dynamic route that we've received via DHCP for V4. So we have a default route at the top there. And then for this demo, I'm doing a tunnel back to my Starlink connection in Anchorage so I can get running IPv6. And so I'm getting that via DHCP. I have a default route down there as well. And I have no loopback. I mean, I have a /64 assigned there to a loopback, so at least I have something that I can ping with. On router 2, it's also very simple. It has no v4 config at all. It just has our BGP template, and we have a connection going in each direction. So we have a connection over to R1, and we have a connection to R3. Same situation. I'm just putting these static addresses in. Don't have to assign anything. It's automatically configured. And here's the routing tables on this system. We see that we have a DHCP default route here for V6. And we see that we have some V6 link local addresses, but I have not assigned any V6 to this. There's no prefix. I'm not actually consuming a prefix myself. So this router doesn't even have a public V6 address. And then if you look at the routes at the top, these are the ones that are really interesting, because you probably haven't seen this often before, which is that it's a V4 route, and then it has an IPv6 next hop there with you can see the link local and the interface.
How many people know what a link local address is? Maybe.
It's an auto-configured interface. All IPv6 interfaces have them. Thank you, Justin. And it is tied to the MAC address of the interface, so it will be unique. It will be static, and you don't configure them. And they're used to identify, because I think we said before, you can't scan the network, but what you can do is advertise your link local address. So everything that talks IPv6 usually advertises its link local address, so you can see what's on the network there. So in true BGP unnumbered, where you are not actually assigning an address to the interface, it is using this discovery mechanism. It's not that it doesn't have a number, it's that you didn't statically assign one. MikroTik can't do truly BGP unnumbered, where in the BGP config, I would just say, here's the interface, talk on this interface, talk BGP on it. Maybe we'll get that someday. We don't have that today. And notice there are no IP addresses on router 2. No IPv4 addresses. There's nothing there at all. But I have a valid route. And then R1 is a little more config, because I'm going to hand this off to the end client. So I have a /24 there of RFC space, RFC 1918 space. I've got a JCP pool. I'm handing it off. And then I have a loopback 10.0.0.1. And I'm advertising both of those routes into BGP so that traffic can get back to me from R3. And then we've got that BGP session over to R2. So this is what our route table looks like on R1. We have similar situation. We have a live V6 route. We have a live V4 gateway, and we have our local there over to the clients. And you'll note, since I did not give any v4 addresses to R2, if you do a trace route, you're not going to get a response back. It has no addresses. It cannot respond.
And this would be similar if you're using v4 and you're doing a trace route, not internally, but if you're using RFC 1918, whatever the space is, the private IPs, and you're going out, you'll see those hops.
Yeah.
But if you're coming from the public internet, you don't see those hops because there's no routing to it.
Right. So this is it. You wouldn't do this in practice. I'm showing you this is entirely doable. So similarly here, so this is I'm just pinging Google's Quad 8 there, and you can see that that's working. And then I'm also pinging IPv6.google.com. In this case, notice everything else actually has a DNS entry because it's Starlink, right? So even R1 has a live internet address from IPv6. And then here's the full test on the client device, a full dual stack connectivity with remarkably little configuration there.
Yeah.
So it was a really fun proof of concept. If you want to see it live, you're welcome to do so. It runs all of those checks and works perfectly fine. There's a couple caveats which I will talk about very briefly, since we are, I think, technically past our time.
No, we're fine.
We're doing good.
We're fine. Yeah.
Oh, okay, good. And what? Oh, yes, quarter after. Yeah, that is so. In the console, in the terminal on Router OS, you can see that we have correct. If I say, show me the detail of these routes, you can see the IPv4 routes here. Then they have the gateway and immediate gateway, which in this case are the same, because we don't have a remote gateway for these. Notice that's correct. If you look in Winbox, do you see what's going on there, Dennis? The upper part is Winbox. Winbox does not know how to handle this. So it's something that looks kind of like an IPv4 address, but it's not correct. So if you do this, make sure that you're actually looking at what the real next hops
Well,
are.
it's translating.
It's translating a portion
it's
of it.
Latvian to English.
And then just what breaks when you do something like this? Since this is not necessarily a full dual stack deployment, this is kind of this mini dual stack. So in a traditional dual stack, if you have a v4 IGP failure, only IPv4 dies. But you're probably going to know about it because I suspect your monitoring is on v4, a significant portion of your customers' traffic's on v4, but they can break independently. The thing that Dennis mentioned with OSPF costs, that's really useful because you want to tie the fate together as much as possible, so you're not trying to troubleshoot an outage that is only in one protocol.
Right.
Similarly, if you have a BGP session loss, maybe your IGP is working fine, but your BGP on top of that isn't working, you're only going to lose the routes of whatever stack if you have that stack isolated. And if you have it unstable IGP, it's going to be specific to that protocol. And if there is a misconfiguration, it can often be asymmetric, right? Whether that's asymmetric paths or, well, I have two sessions to that router, a v4 and a v6, one in the v4, one's working in the v6, it's not, or vice versa. So when you have a core like this, where there's just one stack, then you have half the number of things that can go wrong. Because if v6 is down, everything is down. Now, v6 is stable. I've been doing it for a long time. It's not like this is a higher risk profile. It's actually a lower risk profile. And now you have one set of tools to troubleshoot the problem instead of two different sets. So the blast radius of a problem does mean it's going to be hard down. Sometimes hard down is nicer than having this intermediate state where half of it's not working correctly and half of it is not. If you do make a misconfiguration, it's going to have a bigger impact. It's going to be more obvious. So it's a fun thought experiment. And if you want to try getting that up and running, it's not very much configuration. It doesn't require any special tweaks. So thank you. That was my demo.
Have you tried that with OSPF as your IGP?
Oh yeah, for sure. Like in this case, there wasn't any point in doing OSPF because of just doing prefix delegation on down. But yeah, normally you'd be using an IGP, and then you have your loopback reachability would be handy.
Yeah, so just to go back on something he said is that when you have your v6 and your v4 stack, you have to monitor both. On the public internet's going to be dual stack, okay? You need monitoring on your prefixes on both v4 and v6, especially if you need to make sure, you're an ISP, you want to make sure everything's up and running. And I have seen odd routing occur with upstreams, especially typically smaller upstreams, where all of a sudden they're taking this other odd path with a v6, not taking the normal path with that they take with v4. And usually that's something that they should catch pretty quickly, but sometimes they don't. So you definitely have to watch
BGP
that.
mon, you will watch your routes.
Something else that I use, there's, again, Microtech, we use a script to create the same costs with OSPF v3 as in v4. There's other scripts out there, and I would never recommend anybody running a script just to run it. You need to know what it does, okay? But there's other scripts that we can run at 3 a.m. that will check all of the interfaces in v4 and make sure there's the companion v6 OSPF interface, as well as cost. If the interfaces are there and the costs are the same, it doesn't do anything. But if it doesn't, then it will change anything that needs to be changed on V6, or you can change things from V6 to V4 as well. But that is also something to, whenever your technicians or not your network engineers, when they're doing stuff on your network, especially with OSPF or something like that, you have to make sure that they know, hey, by the way, we're running dual stack. If you're running dual stack, you have to change both. You can't just change one. So just keep that in mind.
There's also a bit of a mentality that you have to get behind that with IPv6, an outage in IPv6 is the same as an outage in V4.
Yeah.
It must be treated at the same severity.
Right.
So if you have a failure on V6, all services are down. Treat it as all services
Right.
are down.
Yeah, so just to reiterate what he said is anytime you have a V6 outage, you need to treat that with the same severity as a V4 outage, because in all practicality, that protocol stack is down and it needs to be treated with the same severity.
Yeah.
On the flip side of that, yes, the internet still works-ish.
Ish. Yeah, and it depends. In this case, once you actually have end-to-end host connectivity, there will be things that are operating that are relying on that. I do this, in my own house where I basically single stack to any service that I'm running internally. I've got a Cloudflare tunnel to it, but I could not do that without IPv6 because I'm behind CGNAT, and I can host servers at my house because I have IPv6. So, lovely.
Any questions, queries, posers, or other informational tidbits that we can